Hi, everyone. Welcome to the April 29th SIG Apps meeting. We have two items on the agenda today. The first one is about the updates on the declarative node maintenance and evacuation API caps. So I think, Philip, if you want, you can go ahead and talk about it.
Okay, sure. Yeah, if I can, I would like to try to share a screen.
Sure, let me add you as host. Yeah, please.
Okay. Okay, can you see my screen?
Yes.
Okay, so since the last time, there has been some major changes to the declarative non-maintenance cap. The main change is that we decided to split it into two caps for easy review, and actually each feature together are independent. Like the declarative maintenance depends on the evacuation, but the evacuation can be used by some other features as well. So this is the cap. I will first try to describe it. What happened? Like, so before we had like a simple API on a pod that we set a condition if we were expecting evacuation. So to reiterate, evacuation is like a safer way to do eviction. So if you want to make sure that your pods are terminated or removed gracefully from a node, we would create a new API called evacuation. And before we had a API, we just marked the pod and expected the evacuator, the entity who does the evacuation, to report to the pod. But there are major problems, mainly with concurrency. So we had also some feature requests that. So this is like a basically end-to-end mapping. So we can have multiple entities who do who request the evacuation, which are called evacuation instigators. First here, yeah. So which are called evacuation instigators, which can be like a node maintenance, as from the before cap, or the descheduler, or the cluster autoscaler, or anybody who wants to move or remove the pods gracefully. And then we can have multiple evacuators. So we could say that an evacuator can be like a controller, like a deployment, or it can be like a custom-made evacuator by a third party that can have like a special handling logic for the pods to terminate and actually handle the requests of the resources well. And then the other entity is evacuation controller, which helps to actually enforce this contract. So this is like a contract between these three entities, and there are a lot of like edge cases and handling logic when you, for example, can the evacuation can change ownership between different instigators own the evacuation during its lifetime. The evacuation can be cancelled, and also that there can be multiple evacuators who can evacuate the pod gracefully. So as you can see, it needs a proper API. So the API is like this. So like from the sorry, from the instigator's point of view, it should be pretty simple. So we just set a pod reference, which pod we want to evacuate, and it should happen automatically. We can also give like a deadline for the responsiveness of the evacuation, but it should be pretty simple. You just select a pod. And the evacuators, they need to register themselves. So we have the evacuators field, which can be added on admission. And the evacuators also need to report the status. So I can go back to it later, but I can show this in a graph or flow diagram where you have the entities as we talked about. So first, the first thing like evacuator should do is mark all the pods it needs, like it supports evacuation of. So this is a difference from the last iteration, where we did not know beforehand if the pod supports evacuation. But for the responsiveness of the system, this is quite important. So so the pod could have like five annotations, and each evacuator can specify a priority of how the evacuation should follow in what order. So first the evacuators, for example, it can be a deployment controller, or it can be some controller which maybe uses a deployment as a base for the deployment of the pods, but it can also do the evacuation. So it can stop the deletion of the pod by the deployment controller and do some custom logic. So this is like similar to like aspect-oriented programming, where we can have like multiple injection points, and before the pod is deleted, it can be handled by different entity until like one entity decides that the pod should be deleted. So once these annotations are set up, the evacuation object is created by the instigator. So then the evacuation controller will observe the evacuation, and it has an important job to select the evacuator. So it will select it first by a priority, and then it will periodically check if there is a response to the evacuation status. And if there is not, after some deadline, it will select the next evacuator by the next priority, and so on until all the evacuators are exhausted, or the evacuator deletes the pod. So the evacuator's job is to actually wait for the active evacuator class, which is set in the annotation. So this is done to help to do the concurrency. So the evacuation controller is the entity handling it. So the evacuators should not like access the status until they have like the power over the evacuation, which is through the evacuator class. And then they can start the evacuation, for example, to migrate the data or finish the computation. It can be anything. And they should indicate the progress by through the evacuation status. And as we said, the evacuation controller will observe the status and make sure the evacuation is really happening. And if it is not, and we have exhausted all the evacuators, we will fall back to eviction. Like this is important part, is that if there is no evacuator for the pod, or if the evacuators are unresponsive, we will always fall back to eviction. So we are sure that there is some entity that is actually like keeping the evacuation in progress. So we do not run into a situation that the evacuation is stuck, that there is some evacuation object and the pod is still living. So if we see no progress, we will evict the pod, and this can run into a PDB. So this can the PDB is after here. So the whole process is before the PDB, and it can be custom. So it's up to the user how it will evaluate. And if we see the progress, then the evacuator can at last decide the evacuation is complete. I can delete the pod, and it deletes the pod. And once the pod is removed, we can garbage collect the evacuation object, and the whole evacuation is complete, and the pod is removed gracefully. So, like, the important part is that we can optionally implement this for all our controllers. I have suggested the solution below in the cap, but there is no rush. Like, we don't have to. This is like a plugin mechanism. So even if our controller, for example, it's hard to support this in the stateful sets, if our controller does not support it, someone can write their own evacuator, which will override the evacuation for the stateful sets and can actually use this feature even if our controllers are not implementing this thing. But the easiest implementation for the evacuation we have right now is through the deployment, and the controller can use the max search to actually first search the pods, and then they can be removed. So we can actually remove pods without losing any availability. So this can be also used for like deployments which have a singular replica set, which until now are not able to be scaled out of the node. And also, so for the stateful sets, it's harder. And then the node maintenance cap, it has like a bigger scope feature whose like a job is to actually remove all pods from a single node or from a set of nodes. So it will depend on this evacuation API, and what it simply does is it can go through all the pods on a node, and it will just create the evacuation objects and expect that the pods are gone from that node. This is like a simple example, and it can be like customized, and so it can happen for multiple nodes, the evacuation of pods. And we can have also a drain plan where we can specify different attributes to actually like ratchet the drain from the node. And this can happen by pod priority, which like many solutions today already do. And we can also, because for example, daemon sets and static sets, static pods are very special workloads, and we cannot downscale them like anytime we want. This could support like this scenario where we can actually have a process for removal of any workload from a node. And we can make sure that it is safe, that, for example, we first remove the user workloads, then we remove the daemon sets, and then we remove the static pods. And we can ensure that through the admission. So yeah, so I have a like a example how this would work, for example, in the daemon set controller. And we would also, the daemon set controller is in a role of the evacuator, but we could also hook into the node maintenance API, and we could observe the node maintenance and decide we can remove the pods only if we are under the node maintenance, because the daemon set pods are tied to the life cycle of the node. And we would actually allow removing pods only in that case and not in other. The similar thing will be done also, like will be explored for the kubelet. If we can remove the static pods and in what scenario, and try to tie this down with like the graceful node shutdown and see what this comes out. But this is to be done. But for this sake, we have a like example how this would look in all our controllers. And the evacuation API is the basis for that. So, okay, yeah, that's this whole presentation. Like, does anybody have any questions?
So, Philip, would you talk about the history behind this cap? I think I wasn't involved in the initial discussion on this cap.
Okay, so first it started like with the node maintenance. We had like a couple of rounds through even SIG Apps and other SIGs. And so basically, uh, like today, when you want to do the node drain or like even through the kubectl drain or by some other solution, for example, like the cluster autoscaler or some other ones. Today there are like multiple problems with how the draining of the node happens. One of the problems is that like one of the problems are PDBs. So when you are like a owner of the application and you want to make your application very safe, you can actually like set up a PDB in a way that like the evictions will not happen for your pods. So if the cluster administrator actually tries to drain the node through the eviction process, which is like the go-to solution today, if you want the eviction to be safe, if you want the pod termination to be graceful, then you do the pod eviction. But actually, PDBs can block this, and this can cause a headache to the cluster admins. So the cluster admin will actually start the drain of the node. Maybe the admin wants to do the OS upgrade or even sunset the node. It can be anything, and the drain will not complete. So the PDBs will block it, and the cluster admin mission then is to decide if the PDBs are important, if it can be overridden and the pods deleted the hard way through the delete or removing the PDB. And this needs a lot of work from the administrator to understand what actually the PDBs are for there. And it's a mistake-prone process. And so, and if we want to be safe for the admin, then like it can be done through the PDBs, but there are like multiple cases where the PDBs are overused in this way, and it causes headaches. And another problem is, for example, when you have like a single replica application, then if you don't want to block this node upgrade, then you cannot use PDBs because you have only single replica. And this replica does not have any chance to be moved gracefully from a single node to other because it is first evicted, which will cause a loss of availability for the replica. And this is not a great scenario for many users who don't need don't need the high availability, or their application does not support high availability, or don't want to pay the cloud cost for the high availability. So they don't want to run 2 or 3 replicas just to support the drain. So they may be okay with the partial like availability loss, but they would be much more happier if their pods were available all the time, which could be done through the max search, for example. So after we like summarize these use cases, we have decided to come with the cap for the non-maintenance. And so this would be like a general API which could be used by other entities, like any node drainers that exist today. They all implement a similar logic to this. They maybe use the kubectl drain with various flags and various overrides. And actually, would be great if there was only one solution, like a reference solution that everybody can use, and they do not have to re-implement it, and it could actually gracefully remove all the pods from nodes. So, and to support this, we saw that we need this API as the evacuation API to support this use case, because we need some kind of a contract between all the entities that happen in the evacuation to make sure that it is graceful, but that we are not blocking the upgrade, that we are progressing, and we need to know if we stop, if the evacuation grinds to a halt, then we need like a back mechanism to actually tell to the admin, these are pods that are not responding. We have tried to evict them. They are still under a PDB. They are bad citizens of the cluster, and something should be done about that. Yeah, not sure if everything was clear.
Yeah, Clayton has his hand up.
Okay.
And I think I was going to develop the question. So it sounds like the intent is, so the core problem, as I understand it, is there is no, the only way to disrupt a pod in a planned disruption. So like that, where the scenario here is focused on, it sounds like this is specifically focused on planned disruption. So we know that in a certain period of time, the node is going away, which isn't under the workload author's control. And the series of the way that Kubernetes works today is that we only have a very hard and one-way mechanism to begin the process of evacuating the node, which is to call the eviction API, which is very one-way, right? If we start doing it, there's no way to cancel it halfway. The pod's going to get deleted, and you don't really know ahead of time which workloads you can evict first and all of that, because it's all hidden under the PDB. Is that an accurate summary of the intent, maybe reframed in my own words, just to make sure that I understand?
Yeah, I would say, yeah.
And then the second problem is that PDB is a very hard mechanism as well, which is, as a limitation of PDBs for stateful workloads, like I know Ceph and Rook had this problem, is the only way to safely protect a Ceph cluster is to orchestrate a PDB with the current mechanisms. The only way that you can prevent being evicted before you rebalance is to set 0. But then the act of doing that prevents a signal. So in a sense, what the design is trying to accomplish is to send a signal that allows a best effort evacuation to take place versus what we have today, which is the only alternative is just go through and start deleting things, and just to do that in a loop. Is that a fair summarization of the second part of this?
Yes. Also, like some entities also don't use even the PDBs, but they block the eviction through the validating admission webhook. So they don't.
Okay, so that's,
yeah.
Is that called out in the CAP? That would be a good one to have. I wasn't aware of that as a.
Yeah, it's there.
What section is it in? Is there any more details about it?
Yeah, I don't know in which cap it is right now, but
Okay.
But I think in the node maintenance cap it's for sure.
I see you mentioned validating emission webhooks down in 3, deeper in the doc. Okay, so I guess maybe PDBs are totally insufficient for handling planned disruption or handling graceful disruption, I think is another way of summarizing one of the critiques here. There also is no way for PDBs to exert back pressure on an evacuation, which is another way of saying kind of what this problem is. I didn't see alternatives considered that really looked at, like, the evacuation API is a big API. Big APIs have big justifications or need big justifications. I guess one of the things I didn't get from the CUP is I didn't get a really strong reason why this is the way that we have to solve the problem, and what other alternatives have been. Like the alternative section didn't really capture for me like some of the things I kind of expected to see there. Are there just other alternatives we considered and rejected? Do we believe that this is the only way to solve this problem?
Yeah, so I think like the main problem which I run into is like we need to solve the dance between all the entities that want to either remove the pod or keep it. And I saw it can be the best done. It can be through a single object. Like it's impossible to do like imperatively today as we have with the eviction API, because we cannot monitor or implement the back pressure.
But
And
won't the
yeah.
But each workload would have distinct back pressure, though, right? We don't have a like in the motivation we talked about workloads that were not HA, that someone hadn't gone to the effort or for various reasons don't want to make it HA, but we still wanted to give them a better experience because this is a planned disruption. Like that's the user, like, is the argument here that we need to give everyone a better experience, even if they haven't done any of the work to make their workload, tolerate being disrupted? And that's like, because this API doesn't seem like that really solves that problem. Or maybe I missed a part. Like it doesn't.
Okay, so like we can improve the experience for like part of the workloads. So for example, we can do it for the deployments, and it can be done for the existing deployments which are running today with the max search. And this is done like without any like problems, but the other workloads would have to like work harder on implementing this feature actually.
So,
And then maybe, okay.
okay.
No, go ahead, Ken.
So I guess to Clayton's point, the alternative that I would kind of expect to have seen considered here, and that in some ways I think might be a little bit more natural, is the ability for the workload inside of the container to express back pressure via a lifecycle hook. There's kind of, I guess there's more prior art to that model, right? Like the nice thing about what you're putting forward here, this contribution, is that it's declarative in nature, which kind of aligns well with the Kubernetes API. But ultimately, like it seems unwieldy to try to express the constraints of like when I'm comfortable being evicted, and via a declarative mechanism. And doing it via a lifecycle hook allows the workload itself to just say, okay, I'm fully replicated or I'm under replicated. Don't boot me off, right? Was there any consideration given to that approach, or no?
Yes, yeah, I was looking into that, but yeah, it's less powerful. That's the main problem. So you cannot, for example, it's not easy for other entities to hook into this process if they want to do, because we have seen that today, for example, through the validating admission of webhooks, they want to have this aspect-oriented like programming style. And if only the pod itself controls that, then it's not possible to do this easy.
Well, and actually to develop that though, like this is something I've discussed with several people over the years. Like PDB is insufficient because PDB only looks at one condition. Maybe as a middle ground between hooks, like along Ken's line, is if there was a condition on a pod that indicated that it wanted to exert, like that disruption would cause hard failure, that could just be a new condition type, and it could be populated by a hook, or it could be populated by a controller. That might be one way to break that particular problem. And that's getting like deep into solutioning, but like I think like to Ken's point as well, like that's also I think my ultimate concern is this feels like we're trying to deal with a bunch of related problems with one mechanism. And I think some of these mechanisms are challenges that are just in other subsystems. Like improving PDB to support time-based back pressure has been discussed multiple times, because the hard, PDBs only support a hard today, but then there's no way to even estimate when a PDB is going to be free, which you kind of call out as a problem. If we could decouple the evicting me will completely break me from the I'd prefer to be very slowly evicted, which I think kind of covers that, the people who aren't setting up HA, but it also covers if you have Ceph, you don't want to rebalance 15 times during a deployment. You want to rebalance once per replica, or you want to evict the replicas that only have to be updated. And so, having seen some of the PDB gaps over the years, I might argue that PDB and things around PDB need to be strongly improved to get at the core problems of PDB. If we did something, if we improved that area, how much of this API would still be necessary? What parts of it could be split apart into different parts of the system?
Okay, so first I would like to at least return back to the pod hook. With this API, because it tries to be versatile, like if it could be implemented even for a pod itself, that it could give a signal either through the API, like through the Go client, that it would see the evacuation and it could respond to that, or it could be done by some other entity that maybe the pod would run some process and it would be on the container level, and we would observe that and then respond to the evacuation API through some other means. So I think this is not still disqualifying this use case. If we can, I think we can return to that in the future if we want. And regarding the PDBs, because today there, I actually don't know how would we go about changing the PDBs without breaking the backwards compatibility. So the evacuation API can be used as a PDB if you are mindful about it. So for example, the entity would see the evacuation and then it would respond, I still don't want to leave the node, but it would have to do that proactively. So I think this is the main reason, the difference, for example, through the PDB, if you just write it, you can leave it somewhere and it does not have to be accurate or for the current state of the events or the cluster. And we have the status for the evacuation, and we actually first select the evacuator, and then the evacuator can either complete fully right away. It can give us the progress, how long it will be happening, the expected evacuation finish time, and then we need to report the progress after some time. If that doesn't happen, it will get evicted. So we have a observability that can be used by all the actors.
Yeah, I mean, I think I agree that those are important things. I don't know that just even looking at the API, this is a very big API that couples a lot of things together, but it makes sense from the context of being focused on evacuation. I think one of my concerns is if we know that there's concrete problems in other parts, a KEP that supplants those, like the PDB concern about backwards compatibility, I'm not sure I completely agree that we can't alter PDB, but I also say there's definitely some things that could be missing. I don't think we can fix the problem of people automatically manipulating PDBs, but I think that they would have to do some work anyway, right? Is the mechanism of it's at the heart of the problem is what people are doing with PDBs right now an intended use of PDBs or not? And I would probably argue that we didn't intend for people to be orchestrating PDBs like that to prevent disruption. And so I think one of my hesitations, I like the design, I like the thought of going into solving the problems, but I feel like all the problems are bundled into one API, which historically is not how we would approach this. We would tease apart, the things that we improve in other parts, especially if there's other people that need improvement in PDB. So that would, certainly at the working group serving, I think we actually wanted to talk about PDBs and disruption and improving because it matters for GPUs, which get disrupted a lot. And stateful sets also have, weird interactions in some cases. I don't think that that's a reason not to, consider or iterate on this proposal. Just for me, looking at it, it feels a lot of things are coupled that could be split out. And that was actually a concern for me.
Yeah, what think about like changing the PDBs? Like if we had because if we want to change today's behavior, it would have to be like an opt-in feature, and it would be like very hard to like for the users to deploy the new behavior and to depend on it, or for other tools who also we use or disuse the PDBs, and this is actually like the advantage of this is that the proactive like actors actually like the evacuation happens before it even gets to the PDB. So yeah, and the PDB still can be used because we fall back to eviction. So if someone does not want the pod to be evicted, it can still block that. And about splitting this into a smaller like features. Yeah, I don't know how I would go about that because there are I have like experimented because there are a lot of like actors, and for example, if you look at from the evacuator perspective, if, for example, we can implement it for the deployment to make it easier for users, but then somebody can implement a better evacuator and it can supplement ours with higher priority. And on the other side, from the instigator side, we also have you can have at the same time like evacuation done by the node maintenance and by the descheduler. So this has to also somehow interact.
I guess the challenge. Okay, so let me give you something a little bit more concrete, right? So this is a notion of evacuation priority, right?
Yeah.
As part how does that interact with priority bands in a general sense? And why would we not like maybe associate the evacuation priority with the priority band of the workload? Like, why would we not want those two components to work together instead of implementing another notion of priority that it's not clear to me how it actually interacts or if it interacts at all with the notion of priority bands, right? If we have a notion of expressing disruption, albeit imperfect, via pod disruption budgets, why would we not just enhance that to express disruption in a general way, or the capability? Like, I guess it is a large API, and it's hard for me to like grok the interactions with other pieces in the API from the perspective of somebody who's actually trying to use it. Does that make sense?
Okay, I will try
If I just want to use this, like I get how it works and it looks fine. But when I think about some of the other APIs that you might be using with the system, it's not super clear to me like how all of those things will fit together and make for a non-surprising user experience, I guess is the way I would say it.
Okay, so yeah, first I will return to the PDB. Because like PDB itself is it's based on eviction, and eviction is inherently problematic. So I think like we could design some convoluted API through the PDB. I guess it's possible, but I don't know if it's the best direction.
But that's a big statement, right? You're saying that a subsystem that is in GA can't be changed or fixed. And I agree, I agree with the parts of what you're saying, but I think like the statement that Ken says that I feel the same way, which was by coupling this to like, we want to really make the planned disruption experience great. And then, each of these workload controllers will plug in and people can build custom. I think one of the things I see is that just because people can plug in and solve their problems doesn't mean that they will. And so the end outcome would be if we have two choices between something that's harder and like fixing the core fundamental behavior of like PDB or getting priority to work a little bit better versus adding something new, generally we would try to fix the existing thing because people are already used to using them. And I'm not saying that it's possible. So I totally accept that there will be obstacles, but having a top-down driven process typically works less successfully in the Cube ecosystem than something that composes well with other pieces. And this feels more like a layer on top than something that's going and improving, like you're right, PDB is fundamentally about eviction. It does not only have to be about eviction. There are plenty of things that we could do around PDB that the step before evicting, like we could have a graceful eviction endpoint that you get called and it tells you, instead of returning yes or no, or instead of deleting the pod, it could tell you yes or no, and then everybody could switch to calling that. There's some options that we could develop. I shared Ken's concerns that it's not improving the core subsystems, it's adding a new subsystem on top of other subsystems.
Yeah, so with the improving the eviction today, or like adding other endpoints, I think the main problem is that it's imperative, and like the imperative is like the problem is mainly with observability with all the entities we have. So
but the counter and like this proposal involves a lot of more objects and a lot of rights, and that's also a cost, right? We don't generally we don't do a lot of rights to objects in the API. Like, that's a tension point. And I would agree, observability is super important. Do not get me wrong. I actually like the declarative mindset. I like the idea that something's recording this, but we do have to be parsimonious about how many rights we do and where. And that was another thing, is like, we're already writing PDBs, and I'm using PDBs overtly, but let's imagine a PDB v2, which is pod disruption tolerance. And pod disruption tolerance is magical, and it inherits from the hard boundaries, and it has soft boundaries. It exerts back pressure or whatever like that. I totally agree that some subsystems should expose some idea of what's going on. But like, this particular design has to justify why this object is the best place to put it. And I think that's like where I'm struggling a little bit.
okay, so like the main issue with if you would like this to be implemented in a PDB, so it's 1-to-n mapping. So you have one PDB and you have 10 pods, and you have to track each pod, and each pod can be actually can be like evacuated by any other entity, and so I don't know if you understand the problem. So I don't see like easy way how to extend the PDB to actually implement all the actors like trying to do their own thing that they desire.
Maybe an enumeration of all those actors. And again, like, I might have missed some of this, but how many actors will there be? There's the person doing the drain, and there's probably an operator for one workload, but how many workloads would have more than one actor on them, right? Like, I tend to think of like a small number of actors here per system. What are the odds that you have tens of actors? Is it high or is it low?
I don't know, but at least now we know we have a couple. For example, the instigator itself, we have, for example, 3. I suspect more, so maybe it could be like 10, because you have different kinds of drainers, and they can use this API. It does not have to be like, if we keep the discussion around the evacuation API, do not go into the node drain. For example, the descheduler could use this to also evacuate the pods and the drainers. So you have like, for example, tens of instigators, and then the evacuators, which is like a specific for like each workload. So there should be at least one, but then you have other controllers which can do like this aspect-oriented approach, that they can, for example, hook into this mechanism and see if like maybe they clean up some part of the state of the pod, or maybe they do just some logging or something. I don't know. Like it. So that there you can have also potentially have like 10 of evacuators for a pod, which can sequentially run after each other.
I'll add some comments to the cap. I appreciate the presentation. Thank you very much, Philip.
Thank you.
Yeah, so let's move on to the next topic. And And for the rest of comments, let's do it in the cap. And next topic is about the in-place image changes.
Yeah, hi. I wanted to take the last 10 minutes to briefly talk about that. So to give some background, pods support that you can change the image of an existing running container in a pod by just editing the pod, changing the image, and as a result, the kubelet will download this new image and restart the container with the new image. And basically, this discussion is about the question if we could somehow support leveraging this capability in the workload API. I more or less coincidentally learned about this in the context of OpenCruise, which is an out-of-tree project that has a bunch of workload APIs that are similar-ish to the upstream ones, but have a bunch of tweaks. And one of them is that they do support this in-place change of images. What's the reason why anyone would want this? So the main reason is basically that's a lot faster. So depending on mostly the CNI and probably the question of if a pod has volumes or not, it can usually take anywhere between 50 to 30 seconds to create a new pod and get it running. Assuming the image is already present in the node, and if it's not, then the time to pull the images gets added on top. And if you have anything large, like a medium-sized cluster with 100 nodes, you want to change the image of, say, a daemon set, this is going to take a bunch of time. So yeah, basically the idea is to make this available through the workload APIs. And I'm actually going to stop here and just ask for your thoughts, because anything else I'm going to say is moot if people think this is a terrible idea.
And I think you are muted.
I wouldn't go so far as to say it's a terrible idea. I think the complexity is high and would need it kept. But I remember the Cruise APIs basically have a modified update strategy that allows like something like try to like update the image in place if you can. Is that the
Yeah, exactly. So the way they do it is they have an rolling upgrade with in-place strategy.
so is the problem that you're trying to solve like basically I want to get, I mean, there's a lot of complexity there, but is the problem that you're trying to solve I want my rolling updates to be faster?
Yes.
And I guess, I mean,
And
is it
and I guess related to that, I want to reduce the downtime of my software. This might not matter in, say, a deployment, but if you have a daemon set with, for example, gathers logs or collects metrics, ideally you want this to be down as little time as possible. Same for stateful sets as well, where you can not just search.
Yeah, I mean, Clayton, go ahead.
I was gonna say this came up with daemon set surge, because when we added daemon set surge, it was in a scenario where you didn't want to have downtime on daemon sets, and the in place in that case wasn't sufficient because it was such a small percentage of likely the number of updates for the use case that we were imagining for daemon set surge where just the image would be updated was pretty low. So it was like, for that scenario, it was like it wasn't really even considered. But there's maybe a broader question, which is why are in-place pod updates so hard? And this has been coming up in SIG recently. We've been trying to get the kubelet fixed to deal with some of its own internal changes. We've added more dynamism. We've added resource changing. It's hard to do in-place pod updates more generally. I think in a couple of years, maybe I could see us getting to actually changing more than just the image. And so then a question would be is in a couple of years, is now the right time to go do this for workload controllers, or should we actually make a case that you could do in-place controller pod changes? Because we're going to have to add flexibility to pods for a couple of things. And the more we do that for pods, the more likely it is that the right thing in the kubelet is to go build the reconciler into the kubelet that tears down parts of the old pod and does all that logic for you. If we had that, what overlapping work here could be avoided, or like, are there things that we could do that would work for image that might also benefit if we change if more parts of the pod could be.
When I look at the expensive operations that are associated with creating a new pod and tearing one down, updating the image, I just never saw, like from the use cases I've seen, is being highly beneficial because it tends to be bounded by image pull time anyway, right? So I guess like my feedback would be like, I think it's still worth looking at, like, if you want to offer a cap and we want to go through the complexity and go through the exercise of looking at like, what would it take to do this in the controllers? Because it is supported at pod today. The cost of implementing it might be low enough where, okay. But I think Clayton's right. Like looking at it more holistically in terms of like, what are the things we would want to implement in terms of being able to do pod updates in place over a longer time horizon, and how does it fit in with that story would be a good thing to have too.
Yeah, of course, but I guess those feels like a bit tangential, because one way or another this would be an if place if possible strategy, which means today there's probably just the image. Maybe in 2 years it's a bunch of other stuff. But adding this today wouldn't mean that if in the future the kubelet supports more changes, we can also make the workload controllers do the in-place upgrades for these other changes unrelated to the image, right? Other in-place changes, I mean.
Maybe I would
So we do
ask.
have in-place resource resizing at a kubelet level now, right?
So
So
that's directly done on the pods by a controller. So that's probably the difference from this scenario. And we do have ephemeral containers, which are done at the pod level. That's not really a container, but and sidecars I think someone has brought up a scenario where a sidecar might want to be updated at a different cadence than the regular workload controller, especially sidecars that are injected, because if you have a security update in like your Istio sidecar, or
sure, that's the one I was thinking of regular off the hand, right? Like rolling out Istio sidecars without having to refresh the pod and push everything through a mutating emission control all over again just to get a separate container image would be.
Yeah, and that gives you a great opportunity to break your whole cluster at once too, which I think is so Alvaro, like this has actually come up in the working group, in the discussions leading up to the working group for serving, because for very large models, you don't want to just like, there's a lot of stuff that you might do for inference and like generative AI where you want to pull a whole bunch of stuff down to the node and you really don't want to disrupt that pod. So a couple of people have brought that up, and I think there are use cases where changing the image might be useful in that context, especially if you're delivering like small content there, where pull times wasn't an issue. So I could see a couple places where this dynamism would be valuable in workload controllers, but most of the use cases so far haven't asked for the workload controllers to be changed as well.
Which could be because almost no one seems to know that this is possible. Like I just asked about this, I think 4 weeks ago, and folks were surprised that this capability exists at the pod level. So yeah. Philip, you want to say something?
Yeah, sure. Yeah, I really like moving this feature to kubelet, because like this would be like to implement this for all the controllers. It could be quite mouthful and have a lot of maintenance. For example, I also do not see how this could be easily implemented for the duo of deployment and replica set. But if kubelet would implement something that if we even create a new replica set with new revision as we do today, and the pod itself would have some flag which would say this is a succession pod, and then the kubelet could actually resolve moving from one pod to another itself.
One wrinkle is that I think one of the goals of in-place update is to be faster, but you're trading it for downtime. So like if you do an in-place update, we stop the container and then we start a new one. So if your startup process takes a long time, it's effectively a max unavailable strategy. So you're taking a hit there, and I don't think we'd realistically be able to support most container images being changed and having the old container still running while we're doing all the prep work for the new one. Maybe like you could do image pulls, but there's a lot of complexity there, which is, I'd probably say almost all the in-place updates are going to be availability impacting. And so maybe then another question would be, is that actually an acceptable trade-off? How many workloads is that an acceptable trade-off for that would use the strategy? Like how many people are doing in-place updates with the cruise examples? Even in cruise, is there any data we could get about how many people, once they know about this, would actually leverage it to justify
I
the
cannot,
cost?
yeah, so I cannot answer that question. I would have to research, I can find out. But for the general availability problem, OpenCruise does have a solution, which is basically that they add a readiness gate into the pod, and they flip this readiness gate prior to changing the image. And then you can configure how much basically drain time you want. And then for this drain time interval, let's assume it's 30 seconds, it flips this condition, waits out these 30 seconds, and only then changes the image. And as a result, the pod gets removed from the service sometime before it goes down and has time to drain.
I mean, it might be worth just reaching out to Alibaba and having them come and give, they have that data, I'm pretty sure, right? So getting their feedback on whether it was more generally useful. I think, yeah. But I guess, I mean, they've worked the built-ins for other reasons too, right? It wasn't just to get this, but it is kind of an interesting signal that they decided like we're going to use our own version of deployment, staple set and daemon set, and kind of fork the existing controllers and go from there.
So if we implement this, we're in the workload controller, then we are requiring the workload controller to remember the previous state of the pod. Then it's not that declarative anymore, because you're not just looking at the current state and current desired state and trying to make the current state match the desired state.
I would say it is, because it can look up the current state from the pod and compare that to the pod template it has in the stateful set, daemon set, and deployment are a special challenge because of replica sets, and then basically see if the diffs allows an in-place upgrade or not.
So workloads controller never compare the pod content. It always use the pod template hash to remember on.
Yeah, looking at the pod's not a good plan, because
Yes.
it looks very different from the pod template spec in most implementations after you've gone through mutating it, mission control and everything else has happened on it. So, but like your meta point is like not wrong, Alvaro. It's just yeah, it's like there's a question of like, should we do this? Should we do this now? And I don't think it's very clear. The how would we actually do this isn't super like it's not crystal clear, particularly for replica set. For a staple set, like for daemon set, like I think you generally would, there's probably an approach that most people would think of. I think for staple set, sort of, but like it also depends on like what you've, on the parameters that you've selected in your spec. For replica set and deployment, it's not clear at all, right? Like, so the feedback you were looking for is like, if I wrote a KEP for this and went and did the research to figure out how to do it, and then we offered a contribution where we implemented what was done in OpenCruise into the mainline, would you guys accept that as a PR and carry the patch? I don't think anyone's saying no, but we also don't have enough data to take a look at it and be like, this is the right thing to do, and we know exactly how it will be done.
Okay, that's fair. I can reach
That is
out
my
to
2 cents. Like I would let Janet
Okay.
and Majek also speak for themselves on that.
Okay, so I can see if I can find any data around this, and think a bit more about how exactly this would look like, and then come back probably. I could
I mean,
also
that's
just
totally
open a
reasonable. I would
minimal.
reach out if it was me and I wanted to push this into mainline Kubernetes based upon like if you're looking at OpenCruise as the feature that is kind of the template implementation that was built out of tree. Ask the maintainers there. I mean, they're and just say like, hey, we'd like you to come to SIG Apps and talk about what you did and like, are you interested in maybe getting some of that taken into the built-in APIs? And we'd start from there, right? Like if there's an implementation that's already floating out there that you like, it's a good place to start. Again, that's my 2 cents.
Okay. It might be difficult for them time zone wise, but I ask. Thanks.
Right. I think we're at time, so let's follow up the discussion maybe through a capped or in the next meeting. Right. Thanks everyone for coming today.
Bye.
Bye.